I would think the average ticket of the item range probably $10, which makes I would get one for green. I also like $2 off 10%. That's like 20%. I mean, $2 off $10. That's like a 20% discount. I think that's going to be better.
Yeah, I was gonna say definitely either there's two options just because I'm not that but like either one.
So in the order, I would do Bugger 5. Number 5.
Yeah.
I would do Bugger 10 over 2 off. Because just from a consumer standpoint, you're getting more value. Like you're getting something instead of $2 off. So I would support that. And then $2 off. I mean, like $5 off. I would expect more customers to spend $10.
I think I agree with that.
What's your name?
I'm Jack. Casey. It's actually
Okay, you all have hypotheses. How many of you think BOGO 5 will be more responded to? Oh, interesting. What about BOGO 10? Okay, so most of the class is on the side of BOGO 5. I think this is one of these cases where economic theory doesn't give us a lot of deep insight into answering this question, but what we are doing is constructing a model of behavior. It's one we're going to test and arbitrate, just like we did with the minimum wage. This one is like obviously not nearly as important as arbitrating whether the minimum wage leads to unemployment, but this is sort of the same kind of idea, right? We're making a claim about how people respond to incentives, and then we're going to go out and test it. Okay, so can someone make the argument for, like, what's the theory for why BOGO 5 would be the one? Casey.
I think the average ticket, like the average amount of money someone would try to spend at a coffee shop would probably be less than $10, around like $5-6.
Okay.
So.
Bless you.
But, I lost my train of thought. Okay. The average ticket's around like $5-6.
Yeah.
With that being said, they wouldn't have to stem away from their normal order in order to get this deal, which I feel like just makes it more applicable to more people.
Next, so most people aren't spending more than like $5. I think the last time I spent more than $10 at Starbucks was forever ago. It's not recently. Okay, so most people are spending not that much. So maybe BOGO 10 is just not going to happen that often. What's the case for, anyone want to make a different case for BOGO 5? Anyone want to make the case for BOGO 10, even if you didn't raise your hand? Yeah.
Just looking at the data we have, there's like 2 transactions for BOGO 10, but only 1 for BOGO 5.
Okay.
And the 2 transactions total more than BOGO 5. So I think it'll be like smaller transactions, but I think they'll end up totaling more than we can get with BOGO 5.
Yeah, this is interesting because, like, you're right. Here we do have BOGO 5 having a very large number and BOGO 10 having smaller numbers. So maybe that might impact how we think about this. Yeah. I'm sorry, remind me of your name? Thomas, yeah. Yeah, AJ.
I would also say like BOGO 10, like compared to BOGO 5, it's like, I feel like it'd be different if it was like BOGO $40. It's expensive, but like
Yeah.
the gap from like $5 to $10 is not like the difference.
So yeah, maybe we won't see a big difference between BOGO 5 and BOGO 10. Yeah, okay. Yeah, Casey?
I mean, BOGO 10 from a consumer point of view could also get more value out of it. Because you spend $10 and then get like $10 additional dollars in value, which is, well, depending on what you consider a better deal, it's like you could get a better bang for your buck in comparison to BOGO 5.
Yeah, I mean, in some ways, like, what the deal is here is like 50% off. And if I'm giving you 50% off a larger amount, maybe that just, that's like, oh, even more 50%. And so you buy more. Yeah, James?
I think BOGO 5 I would see Logo 10 being incredibly competitive with Logo 5 is for office orders. So people that
Oh,
get
yeah.
coffee for their
With coworkers.
coworkers.
Yeah.
That's what I was thinking. The people who come for their coworkers, like if you're gonna get 4 things of coffee, you don't use the Logo 10.
Yeah.
So at least you're actually using one.
Yeah, so maybe, maybe, like, the reason people are using these BOGOs, like, I wouldn't buy 2 coffees,
Yeah.
unless Maxine kept me up all night. But yeah, so maybe that's the use case, is like buying for someone else. Yeah. Okay, so part of the idea here is there are competing ideas. Like, you can build a model on either side of this. The same is true of the minimum wage. Like, we have many models of minimum wage and the impacts, and what we did at the beginning of the semester is rule out one of them, which is the one you've seen before, but it's not the only one. What we're going to do today is try to make a case for one of these. We're going to try to arbitrate which one of the models is more correct. Okay, so great. So hold on to your hypothesis, and we're going to spend the class period working through it. So what we're going to start by doing is just getting in the data. So we're going to, go in and visualize the averages. So we're going to look at which offer has a higher average. So the thing to do is to hop over to the course page. You don't have to use Duo Mobile. You click on the notebook. What do you do next? Save a copy. File, save a copy and drive. When you save a copy, then you can run the first cell to load the data. And if you wanted to, you could write down your hypothesis at the top. How does incentive structure affect buying behavior? And then you could write down whether you expect BOGO 5 or BOGO 10 to have a higher average. Okay, so your job, the first thing we're going to do, this is kind of a warm-up, is to use some of the tools we already have to visualize this data. So I haven't given you any visualizations yet. What we're looking to do is use one of the tools we already have to visualize numerical data by category. We'll talk about how we do this in a second, but I want to give you sort of a blank slate. I'm not going to guide you. We'll take about 2 minutes here. I want you to start by thinking about what you might do, try to implement it, and then check with someone next to you whether they think what you did is a good visualization. You can check the slides, but I recommend against it. I did not.
It was a great day to ride the bikes. I hopped on the closer before my last race.
Oh, nice.
I got the class slowed up.
Was it one of the electric ones? Yeah.
I love them Togas.
Yeah, they're fun. Yeah, my bike, the one I commute on, is electric. So I'm just like cruising around.
It's so fun riding with Togas, man.
Yeah. Okay. I don't think many of you checked with each other.
I forget what block that they averaged out.
I think that was last 5 and then compare the mean or the medians. But still, it's like hard to visualize what it is that really means, to be honest.
I would just, I feel like the easiest is just take the average of all the tree connections and replace them. But that outlier, I don't think there would be extreme outliers in this case. Because an extreme outlier would be like a number like 0. Or like a number like
For some reason, I was getting like 1,000. Like there was values with like 1,000.
oh, well,
Yeah.
that's a big mark, right?
Oh, okay.
Okay, someone help me out here. Yeah, James.
So,
No one heard it.
this is my idea. Okay.
Yeah.
My idea was I was going to do a graph that has the length, it has len of the offer ID.
Okay.
So you do the amount of transactions that were done with that offer ID.
Yeah.
And then you would do a graph that was, within that has the average amount spent
Okay.
on per offer.
So like average and count.
And,
Uh-huh. And so we have 2 dimensions.
yeah, but
So
I don't know
scatter
how
plot.
we would do it.
Okay. You could do it with a scatter plot. This is not the way I recommend for this question, but you could do it. Anyone else do something different? I heard someone do something correctly. I'm curious. Anyone do a box plot? Nice. Let's do a box plot together. You can also see it in the slides. We've done box plots before. Using a box plot is not a new tool. We're using it in a new environment. In the past, we've worked with time series data. We've plotted the distribution of seasonal patterns, so prices within a month, and then we've done that across months, which allows us to make distributional comparisons through time. We also compared years, so the distribution of coffee consumption per capita. If you remember, we used a multi-box plot to show the how those distributions have changed. Here, we're not talking about time. We're just talking about different groups. So we have a numerical variable, but we want it to be broken up by category, not by time. But the fundamental idea is exactly the same as we've used it before. Yeah, bless you. All we need to do is call Seaborn, so sns.boxplot. And then I'm going to give it the data. Our x-axis, I mean, you could set this up either way, but for our purposes today, I'm going to use x to represent the categorical variable. So x will be offer ID, and then y will be the value that we want plotted. So this is revenue. And then the last thing I'll do is just add a whisker. So this will be whis between 0 and 100, just so we don't have any outliers. And when I plot this, I get this thing. How many of you created a figure that looked like this? Hands up. Okay, so the point of our visualizations is to be informative. If I were to ask you whether BOGO 5 or BOGO 10 has a higher average, what would you say? It's very unclear. Why is it unclear? Yeah.
You can't really see any of the quartiles or like where the actual function is in the box initially in this curve.
Yeah. All right, Bridget, right?
Jaden.
Jaden.
That's what
Bridget, okay. Jaden. Yeah, so Jaden's saying, I had a friend in college whose name was Tyler, and our professor, we took a lot of classes together and we'd sit next to each other, and no one could ever remember our names. Do I lose lecture points or do I get lecture points when I get your names wrong? I can never figure this out. I think I get lecture points, right? Because we're getting things wrong. Okay. So yeah, I'm now 10 lecture points. I'm in the lead. what Jaden is saying is we have like the scale is funny here. We can see that we have like the upper whiskers takes up nearly all of the distribution of the box. So this is not very easy to see. If you look back in the slides, I've basically done this, just plotted this. So you can't really see the distributions because they're all clumped together due to the upper whiskers. We also have this informative category on the end, which has, I mean, from here, it looks like there's no distribution at all. You can also see some people are spending $1,000 at Starbucks. Is this like a corporate order? Maybe that's what this is. Any ideas for how we might fix this? Yeah, Erwin. So yeah, we can convert this to a log scale. One of the values of, or the use cases for a log scale is to compress the outliers, the large differences, and then decompress the small differences, which seems to be exactly what's going on here. Has anyone done a log scale on this data yet? Just Jagger. Okay, so let's, I just want to give you a little bit of a picture for what a log scale is doing in this case. Here I've already logged using logbase 2. I've logged revenue. So this is like business speak for how much people are spending. So I have, you know, the values themselves. And when I take a log, I get these numbers. Logbase 2 is just every unit increase is a doubling. So if I go from 1 to 2, logbase 2, I'm doubling the revenue. I created a little figure to show what's going on here. I've actually, so on the horizontal axis, I have revenue, our x variable, and then on the vertical axis, I have the logbase 2. And you can see this is what's happening when we take a log, is it sort of flattens out. So you get lots of difference in small values and not much difference in the large values. So these large values are sort of compressed on the vertical axis. Yeah, James?
So looking at this and looking at the last one, I'm like still slightly confused on like, as you explained like why you do this a lot.
Yeah.
But I'm still confused on why you do this a lot. Like, I don't understand like, what it's trying to tell you.
Yeah.
But based on the list, like, it makes me think that between certain brackets, it's gonna scale it down to some one-digit numbers. But I don't know why you would do that.
Yeah, so the question is essentially why do this? The first reason, and for our purposes today, this is the main reason, is we can take these large values, and so if we go from 400 to 600 on the horizontal axis, that's a very large difference.
Yeah.
If we run that up, you can see 400 would end up here, and then 600 would end up here. So that very large difference on the horizontal axis becomes a small difference on the vertical.
But then how would you know which one numbers is what?
Yeah, so this is sort of the problem with interpreting log values. We often use logbase 2. Sometimes we use a natural log, which we'll get to. There are reasons we use each one of these. For our purposes today, logbase 2 makes some sense. What it tells us is going from 2 to 3, we're doubling on the horizontal axis. So if we go from 2 to 3, the horizontal axis is twice as large. If you go from 6 to 7, you're going from here to here, which is about twice the distance. So it sort of compresses it into a scaling. Yeah. Does that answer your question?
It does. I want to see what I do, but it does answer the
Yeah.
question. I'm trying to understand.
Yeah, if you feel like interpreting what a log is doing is a little complicated, that's because it is. It takes a while to get familiar with how to think about logs. And in general, like interpreting a log scale is just always going to be harder than interpreting a linear scale. But we're gonna do it. So Jagger's already done this in his code. What we're gonna do is take a log and then plot the multi-box plot of the log base 2 of revenue. I'm gonna give you some of the code here. This is the log transformation. Here I'm using log base 2, and then we're doing 1 plus the data, just so we don't end up with taking a log of 0, which is undefined. So we can put a 1 inside the log. If you wanted to use a different log, feel free. It's not going to radically change what we're doing. It just makes it a little bit harder to interpret sometimes. So we'll take a minute, create the box plot, and then show it to your neighbor, who will tell you that you're even better than you were at coding. Okay. Does this one look better? This is one of those common situations you'll run into. Working with skewed data can be, especially when we're dealing with prices, it's almost always better to take a log. So all I'm gonna do, I mean, maybe I'll just copy the code, which is very uninteresting to watch. But yeah, if I construct log to revenue and then create a box plot, so sns.boxplot data, then this will look a lot nicer. Bot plot. So this is the box plot. I'm also going to add, well, let's hold off on the strip plot for a second. Let's talk about what we're seeing here. How many of you got something that looks like this? Okay. I want you to turn to your neighbor and tell them why you think the box plot looks like this. There's a good reason. Why does the box plot look so strange?
Maybe because like all the smaller values are getting pushed to like value 1, so you can add just all the same like.
My box plot was funny. Oh, I know what you're saying. I didn't put the log. I thought you had to do Okay. Alright, repeat what you just said.
I'm kind of guessing, but I'm assuming like all the smaller values like revenue are getting pushed to like the same value. And then when you take a log of that, it's just all of these more together.
That's really a big yeah, and I bet like
Yeah, it's a block.
Wait, are you reading the mean? Yeah,
It would be like this tiny value, but like it's like you can't even see like any difference.
So because we took the log,
yeah.
the median, min, and like Q1 were all just very
Okay.
Yeah.
Someone help me out
Yeah,
here.
you can't really
No, you're not.
Why are we seeing the box plot looks so weird? Okay.
So then the revenue field is like undefined or NA or something like that. So
Okay.
adding 1 doesn't actually increase it, it just stays at 0.
Yeah.
So all those offers that aren't utilized will bring down the median transaction as well.
Okay. So you're saying the median is actually down here?
Yeah.
Okay. So we have lots and lots of zeros. Yeah. Okay. So because we added the 1, and then, so when you take the log of 1 plus, if there are a bunch of zeros in our data set, log of 1 plus 0 is just 0, so it stays at 0, and we're seeing a lot of zeros. So essentially we're saying there are many, many zeros in our data set. What else? Any conflicting opinions? How many of you added a strip plot? A couple people. So let's add a strip plot and see if this makes more sense. So SNS dot strip plot. Data x is equal to offer ID. Y is equal to log 2 revenue. All right. So does this confirm our idea that there are lots of zeros? Yes, there are lots of zeros. We can't tell how many there are because they're all stacked on top of each other. But we can definitely tell that there are lots of zeros. We can then tell from the box plot that more than half of all of these are zeros. Because the median, we have plotted it, it's just the same number as the minimum. So we've essentially squished the bottom half of the box and the bottom whisker to be exactly 0. Which is exactly what Ryan was saying just a second ago. So we can see this. We have a bunch of zeros, and then we have a big jump, and then we have all the rest of the data. So as like a little bow on top of what we just did here, we went in trying to find which one of these offers gave us the highest average revenue. We could just compute that number. Like we go in and we compute the average transaction amount. But what we realized is we wanted to take a look at the data. So we created a box plot. The box plot was not interpretable because the scale was wrong. We then de-skewed it, which allowed us to see this, which then allowed us to see that there were so many zeros in our data set. In fact, most rows in our data set had 0 revenue, which means nothing was actually transacted. What do you all think of this? If we take the average, is this going to give us a good answer to our question? Turn to someone next to you. Tell someone how you would feel keeping the zeros in.
Zeros skew everything.
So if you take the number out, you just can't get close to 0.
You already know more than half of them too. Zero means screwing everything. Like 1's better than 0.
Yeah, so all your values can probably
But if that's the case, I still think it may be valuable to have this
Okay. Should we keep the zeros? How many of you say yes? How many of you say no? Okay, even though no one answered to keep the zeros, I'm looking for someone to represent both opinions. First off, why should we get rid of the zeros? Yeah.
They skew all data points, and so it's difficult to see any sort of trends in the data.
So yeah, so we're skewing distribution, there's just a huge clump at 0, and then there's everything else. Yeah, so it, like with the box plot, it's hard to see, and then with other statistics, it would bring the number down for sure. What's maybe another reason why we would want to get rid of them? Like maybe going back to our original question, there's something like how do these offers change behavior? Like which ones change behavior the most? Anyone want to make the argument for keeping them? Yeah, right.
If the goal of the offers are to get people into the store, we want to know how often the offers are being redeemed.
Yeah.
To see if maybe you're just sending them out too often, and maybe the BOGO 5 is being redeemed at a really high rate, but the other 10 isn't. You're just sending it to more people.
Yeah. So maybe we would want not just how much people are spending once they redeem them, but also sort of to include this redemption rate, like how often people are actually using them. Yeah. So depending on the question you're asking, keeping them in or removing them might be the right thing to do. You can go both ways on this. Yeah, Corey.
Is there a way of just collecting the data of how many zeros there are, so the data is not as skewed, but still having the data on the zeros as well?
Yeah. So I think the skew here isn't like it changes the look of the box plot, but I'd actually be pretty comfortable including it, just like in the data set, and then we can compare averages and such. So that would be just one way of handling the problem, is just leave it in, and then we know just like most of the data is zeros. So yeah, I think that might be the simplest approach. Yeah, does that answer your question? Yeah, good. James?
What's informative?
Yeah, so informative, this is a thing that gets sent to your phone. No one is actually spending money using it. So you tell me. So like when pumpkin spice lattes show up in the fall, in the past I've received a little ping that says, pumpkin spice lattes are back, but no promo. So no one's redeeming that, and it's just being sent to their phones. Yeah, James.
Why is there big gaps in some of those step ups? Yeah, I mean, not step ups, but step ups.
Yeah, so question, why is there a big gap in the strip lots? Someone want to answer this? Any ideas about why this might be true? Why do we have this big gap? Yeah.
You can only use the deal if you spend at least $5.
So to get the BOGO 5, you have to spend at least $5, and then the second thing gets added. So there's a jump. Either you don't redeem it, or you spend $5. Yeah. So 5 is just a little bit larger than 2 times 2. So it's just a little bit larger than 2 on the log base 2 scale. Yeah.
Is there any reason why you would include informative?
So I think whether we include this or not isn't going to make it's not going to impact our comparison between the others. So just showing it, I think, isn't going to change anything about our statistics. I think if we really don't care about it, so we can just exclude it. The reason I included it is I just didn't want to do that step. Yeah. Yeah, good. What else? There's one other strange thing maybe we'll come back to. But I think this is pretty good analysis, right? We've gone through, we've let's see, I lost my train of thought. No, we're all good. the process was we used the visualization. We found the appropriate visualization, which required us to take a log, and then we plotted using a box plot the distributions. I think in addition to the box plot showing the strip plot gave us extra insight about what's going on here. We thought it was strange the box plots had were squished all the way down to 0, and we figured out using the strip plot why that was. So I think the strip plots and box plots in combination are incredibly powerful in these kinds of situations. The last thing we're going to do is, or not the last thing, but one of the last things we're going to do is actually focus just on the non-zero data. So why are there so many zeros? Let's try to figure out why there are zeros and then how we can handle the problem. I'm going to give you a bit of a clue. We're going to try to summarize what's in the event column. So this is maybe a test of your part 1 skills. I want you to summarize the event column. So let's take a minute here. You just wrote a mini exam for me, but this is another chance for me to test whether your part 1 skills are working. Try to summarize event. Remember what we're looking at? We're looking at this table, and we're trying to summarize just the column event. This is not a test. Don't treat it so intensely. So summarize and then turn to your neighbor, tell them what you did and what you might do, or what it tells us. Okay, someone help me out here. What are we doing? Not an existential question. Yeah.
SNS count plot.
SNS count plot. Perfect. SNS dot count plot. Data, and then what are we counting? X equals event. You could also use value counts if you wish. Maybe I gave away information about how to do this. I didn't tell you to use count plot, and this is exactly what I would use. So what do we see here? Someone, well, have you described this to your neighbors? No. Tell your neighbors what you're seeing, and then you'll tell me.
Most of them? Oh, sorry, you guys.
Okay,
I was just gonna say most of the offers are not. There's a lot more offers that are not transactions, so that's why
I mean, yeah, that makes sense though, because in order for it to be a transaction, there has to be an offer. And in order for the offer to be complete, there has to be an offer. To be honest, even the order out there, the offer can be a transaction, the offer so you can get a better visualization of the process.
So yeah, I definitely. It might be better to sign a plot offers because then that shows like how customers are actually using the offers. Instead of like including all the other things that just don't really.
With that, what they right next to me, you can almost come to like a percentage.
All right. What do we see? Someone describe this to me. Right.
There's more offers sent out than transactions completed, and there's more transactions completed than offers completed.
Okay.
So depending on what you're actually looking at, you might want to
Okay. So we have lots of offers that are not taken up. We have lots of transactions. Makes up definitely less than half. And then we have some offers completed. How do we know which ones to use? Should we look at the data? So we'll spend 30 seconds here. I want you to summarize the distributions of revenue, maybe use log revenue, by event type. So we have 3 different events. We want to know where revenue is coming from. So display the distribution of log revenues for each one of these types.
You know, when I hear the word distribution, I automatically think Instagram.
Yes.
But I realize Instagram is usually not the best option.
It's not the right one for comparing between categories. Yeah.
And pie charts are awful.
Yeah. Okay, someone help me out here. What are we doing? What are we doing after this? We want to know where revenue is coming from, which would be helpful to know the distribution of revenue across these 3 different categories. Any ideas?
Oh, why not just another bar chart? Or graph?
Another bar? How would we?
The revenue on the y-axis.
Okay.
And then on the x-axis, you put offer completed transaction offer.
And then we just go through and add up how much revenue is coming in total. So yeah, we
I
could.
say we do a pie chart.
So Casey is saying pie chart, and I disagree. We could, one of the other ideas was we could go through and just add up all the revenue by each one of the groups. Totally appropriate way to go. Yeah, James?
Why don't you do a group where just the offer completed?
Yep.
And then, well, you do that and then you query about offer completed, and then you just do all the calculations based on the only ones.
Yeah, so we could create groups and then find the total revenue by group. Yep, so that would be an appropriate way to go. We have another tool that we just used that we could use. Yeah, Ryan? And how would we write the box plot?
Basically the same way, but instead of offer ID to
Okay, so let's use James's approach. I think you can use. We've not done a lot of grouping, so it may not come super familiar. But with a box plot, this is something we're very familiar with, and we can just write real quickly. So sns.boxplot data. We have x is equal to event, and then y is equal to log to revenue. If I run this, we can see exactly what's happening. We have no distribution for offer completed. So there's no money coming in from offer completed. There's no money coming in from offer. The only source of revenue is from transactions. So if we're trying to exclude all of the zeros, we know exactly what to exclude. We exclude everything that's not a transaction. Okay, any questions? Any quibbles? Casey?
A pie chart.
Well, we have more than 2 categories, so I wouldn't use it. I think when we're comparing, in this case, a pie chart would just be the pie is totally transactions.
Well, yeah, but like, I mean, it's kind of intuitive. Like now that you made that graph, it makes sense how all the revenue came from transactions.
Yeah.
But let's say it was evenly like distributed, not even evenly distributed, but let's say like the other 2 weren't 0. I feel like
Yeah.
the pie chart would have visualized that more than fine, illustrated that.
Yeah, I think when we have 2 groups, pie charts can work.
Even 3 or like 4.
I think 3 is maybe, yeah, I think in general, when we have more than 2 categories, a pie will display the data. But I think when we're working with more than 2, a bar, in my view, doesn't work as well as a pie.
So you think it's based off like the number of variables instead of the distribution of the set data?
Yeah, I think
Because
so.
It's like 3 variables and they're all like it's over 10% per variable. I feel like those
Yeah.
easily illustrated. Or even 4 variables and it's 20%, 25%, or 5 variables and it's 20%, or so on until it becomes too small to see.
Yeah.
It's based off the.
Let's chat about this after class. Yeah, it's a good question. Yeah, one of the conclusions is there are multiple ways of displaying the same information, and we generally think some are more effective than others. In this case, I think a bar chart is fine. There are definitely other ways of doing it. So what we're going to do next is filter just for the rows where we have transaction. So we've worked with some filters already, but we're going to spend a little bit more time thinking about how to do this filtering. We just want transactions. We don't want offer completed and we don't want offer. We just want the transactions. Yeah, we're going to work through a filter. Yeah, Tanish.
Exercise 2.2, was it just the box class with a strict in that time?
For the upload into Gradescope?
Yeah.
Yeah, so any one of these figures would be would work for the upload. Yeah. So let's create a filter. The figure I actually want to create for the end is right after the filter. So you've spent a little bit of time with filters. I want you to do a little bit of filtering before we do it on screen. So there's some code in the slides. Let's spend maybe 2 minutes here getting familiar with the filter. Take a crack at it, and then we'll do it together on screen. Didn't mean to shut that conversation down.
No, it's cool. I was getting off topic. The time in this class is a little bit. We're not
Yeah,
going
yeah.
to spend the whole time talking about pie charts.
We spent a little bit of time at the beginning of this semester. I think it was part 1.1.
Yeah. Talk about how like in most data analytics, like you're not going to use a pie chart.
Yeah.
But me personally, I'm a fan of pie charts. I always like
Yeah.
pie charts. So I'm like, why not? I'm tired of bar graphs.
No, I think it's so the standard wisdom is like we should never use pie charts.
Yeah.
That's what like a lot of classes will teach you, and I think that's not quite right.
Yeah.
I think it is true that sometimes pie charts are better. I think when we start adding like lots and lots of different categories,
Yeah.
then it becomes harder to read. But you might be right. Like for your eye, looking at a pie chart is, even when there are 3 categories, might be the easier one to read.
I feel like it's based off of more like the distribution of set values instead of how many values there are. Like, I don't know. If we ask everybody what's your favorite color, and everybody picked red, white, yellow, blue,
Yeah.
we had a pie chart, and as long as like blue wasn't 1%, it would be pretty easy to
Yeah.
visualize, especially in comparison to other ones. I mean, bar graph is cool, but
Yeah,
I'm tired of
bar graphs are boring.
boring. They look like redundant. A pie chart looks like professional. I didn't really look.
Interesting. Yeah, I sort of like when I look at a pie chart, I don't think professional,
Well,
but
yeah.
but like, like opinions can vary, and that tends to be fine. You do see a lot of pie charts on like internet forums.
Just wait in like 5-10 years and change the whole Like, we'll change the whole narrative.
And I'd give you respect. All right. Someone want to tell me how they did a filter? Yeah, Irvin.
Create a variable called mask equals data event equals transaction and then file mask.
Can you start that over? I missed the beginning.
Mask
Mask?
equals data
Okay.
bracket event equals transaction.
Okay.
And that's, pretty much even just
Okay, yeah, so nice. So event, and then equals, and then transaction. Okay. And so Erwin's doing this in 2 steps. By creating a mask. So this is just a list of true and false. So if I list this out, we have mask. This is just a list of true and false. The single equals is an assignment operator. This is saying I'm going to define something as something. I'm defining mask as a list of logical checks. I'm going to go through each one of these rows and check whether in that column event it's equal to transaction. And then just returns true and false. So then the last thing Erwin did was we had transactions was equal to data, and then in brackets we put in mask. So then this is just returning for us only the rows that are true, only the rows where the data returns true. You can do this in 2 steps. For me personally, I usually just put all of this inside the bracket. So we're just checking row by row whether the column event is equal to transaction. And that just gives us only the data for transactions. And we can just call it transaction. Either way you go, it's computationally identical. It just, some people like writing it one way versus the other. Yeah, James?
Is this different than doing a query? Or is this the same thing?
Yeah, queries are, you can get more complicated with a query. Yeah, the queries are a little outside the scope of this class, and I don't use them that often personally. But there's like a whole system for doing queries that allows you to do like slightly more complicated stuff. So you could do all of this with a query. But that requires using like query syntax, which is, yeah, something else entirely. Yeah, great question. Any others? Y'all want to learn queries? Okay, I agree. But if you like queries, you can use them for sure. So here we have transactions, so we've done the filtering. The next thing we're going to do is visualize this filtered data. Essentially, this is the exact same step as we've done before. It's the only difference is that we're only using this transactions data set. And if we've done everything correctly with our filter, we're not going to see any of the zeros. So I'm just going to write out a nice little box plot. So we have sns.boxplot. We have transactions now, which is our data set. And then I have x is equal to offer ID. And then for y, we have log base 2. Log 2 revenue. And then we'll just use whiskers equals 0, 100. And that looks like this. If we wanted to add a strip plot, we could do that. It would look like this. I think this is the clearest visualization of the data so far. This still doesn't look great. There's still a lot on the strip plots. But in terms of visualizing the data in a clear way, this is the best so far. I've cleaned this up a little bit in the slides, so I'm going to jump back over here. Yeah, James.
What's the translucent?
You can use alpha. So an alpha parameter in the, so it'd be like alpha is equal to 0.1. So just the opacity to make it transparent. The other thing you can do is add sample. So we can just do sample 1000 and only include 1000 of the observations. or 100. So you can do it like this. Either way you go, that can be in the right direction. Okay, so we're near the end of class, and we haven't fully adjudicated whether BOGO 5 or BOGO 10 is has the highest average revenue per offer, per transaction. Yeah, James.
Like, don't you know that? Logo 10 because region is high?
We do. Yep, so now we're in the ballpark of being able to answer it. So someone tell me, BOGO 5 or BOGO 10? Hands up for BOGO 5? Hands up for BOGO 10? How many of you were correct? Got our back corner and Ryan. Okay, so this is interesting. Do you feel bad that you weren't correct? No, of course not. You put your hypothesis out into the world, you test it, and if you're wrong, you've done good science. Or at least as long as your process is good, then you've done good science. Being wrong is not a negative. All right, so I'm just gonna run through a couple extra things. This is really like most of what we've done. The last thing we could do is this grouped statistics, which is actually very similar to what James was saying earlier about finding like the average revenue by group. But here we're going to do it by offer ID. So this is just a summary table. You're going to do something like this in your homework 2.2 using groups. And this is just a summary table of the average, the mean revenue by group. The box plot shows us the median. Here we have the mean. And we can see BOGO 10 is definitely larger than BOGO 5. And so the process, just as a summary here, we did a bit of a filter just to select the rows that we cared about. We've talked about filtering all semester. I've mentioned it almost every class. Today we actually used it. We've done it once before, but it's truly the first step of any kind of workflow. We then did a log transformation. We grouped by the categorical variable. We didn't do this explicitly. We had Seaborn group for the box plot. But behind the scenes, what we were doing was creating groups. And then Seaborn gave us box plot and strip plot by group. So we were summarizing in that way. And then our summary table also gave us the average and other summary statistics. One of the things to notice here, the process we followed today was not linear. We didn't sit down and know exactly what the steps were going to look like. We doubled back a couple of times. This is how we do it. It's not linear. We didn't start with a filter. You remember, we started by grouping and summarizing. And then we realized we actually needed to transform. And then once we did the transformation, then we needed to filter. So the discovery process doesn't follow this flow. But the process that we followed to construct our final answer, our final analysis, followed these steps. So this is not to tell you the correct steps to take when you first see a data set, but it's to tell you the steps we take as we proceed through our analysis. So the last thing, and sorry to run up against the end of time here. It was great discussion today. I appreciate it. There's one extra thing here. One thing we can do is just compare the two directly. So we looked at all of the different groups together. But often what we like to do is compare two separate things to each other. So this is just, if we were to set this up and then make this comparison, we could do this directly. The last thing I want to leave you with is sort of to set up part 3 where we're going next week. You can see we have two distributions. Definitely BOGO 10 has a higher average. But the other thing to notice is that most of the data, most of the distributions overlap with each other. So it's certainly not the case that BOGO 10 will always yield a higher revenue than BOGO 5. There's so much overlap. I've just highlighted a little bit of the overlap here. You can see, this 75th percentile is, for BOGO 5, the lower one, is higher than most of the data for BOGO 10. So most of the data actually overlaps. And the question is, does this mean, because most of the data is overlapping, does this mean that BOGO 10 is actually higher? So on average, it is. But does that mean BOGO 10 it actually has a higher average revenue? It appears to be in our sample. But these are the kinds of questions we're going to be turning to. We can see what's in our sample, but if we were to go out and look at it again tomorrow with new data, would we still see this result? Those are the kinds of questions we're going to start answering in part 3. If this looks like a t-test, it's because it is. Nearly everyone in this class has run one, but we're going to spend a lot of time thinking about the intuition for where the t-test came from. Sorry, James. Yeah. I'll see you on Thursday. Homework 2.2 is posted.
We have a lot of investor
Yeah, so it's sort of like what I know you're saying.
First one. I did it for the next one, and I did it.
Yeah. So we're dealing with
I've never done that.
this thing.
Yeah, exactly. That's what I'm talking about. Like that one is all the ones, and it's like the log basically tells you like how the revenue correlates with the different log types,
Yeah.
which is necessary for later on down the line.
Yeah.
But this by itself wouldn't have been enough in order to tell you about.
That's right. Totally. Absolutely.
Yeah.
Yeah. So if that was your question.
Yeah, that's my question.
Yeah.
Okay.
That's so good. Yeah. That's a good clarification. I might put that in the notes actually.
Thank you.
Yeah.
Can we get time to discuss the exam right now, or should I wait?
Yeah, we could sit down. You want to come back to my office?
You might as well have to die.
Yeah, I know.